Good morning or evening, whenever you're watching this. I just want to take a moment to go through the study guide for the Foundations of Chemistry unit. That's weird. Oh, it's that one. Okay, that's fine. It works. All right, so for the test, you should remember the vocabulary that the atom is the basic building block of matter. That's what we started with. That elements are a substance that's composed of only one type of atom. I didn't touch it that time. When you have a compound, you have two or more elements that are chemically combined. So, like carbon dioxide, CO2, they're joined at the electron level or the chemical level, so they are called compounds. These are the ones that have formulas. And only a compound would have a formula. We did talk about mixtures. Remember, mixtures are two or more materials that are physically combined. I can separate them. Very easy. They are not combined at the atomic level in any way, shape, or form. We actually did separate them not too long ago. Part of that was a solution, which is a homogeneous mixture. So when you dissolve like salt in water, you are creating a solution. It's basically separating all those salt molecules evenly throughout. Remember, it's a physical change. The solute is, in this case, it's the salt or the Kool-Aid being dissolved. The water is always the solvent, the material that's doing the dissolving. Then we talked about physical properties. Remember, physical properties, if I see property, I should understand it's a characteristic of matter, and we can observe that with our senses, and it doesn't change what it is. So things like color, shape, mass, volume, length, magnetism, those are all things we can observe without changing the material itself. Remember, chemical property is a characteristic that allows matter to change into something new. So again, when I see property, I should know it's a characteristic. Also, when I see a chemical, I should know it's going to change into new materials. Things like oxidizing or rusting or burning. Those are all, if they can do that. Again, that's a property. It means it can do this. Hasn't done it yet. We talked about the three states of matter. We talked about the solids, liquids, and gases. Solids have a definite shape, definite volume. Liquids have no definite shape, but they do have definite volume. They just take the shape of their container. And a gas has no definite shape, no definite volume. The particles are moving really quickly, and they will fill up the container that they're in. We also talked about the physical property of density. Density was found by mass per unit of volume. So if we know the mass of an object and the volume of the object, we can figure out how dense it is or how much material is packed in that material. Physical change is a change in size, shape, form, or state. So if we change, we're not changing what it is. So changing, boiling, evaporating, you break a glass, it's still glass. Chop wood, it's still wood. It's just changing its size, its shape, or its form. And again, if I see change, I should know it's a change. I apologize for the dings. Someone's trying to reach out to me, but I'm busy right now. Chemical change, one material changes into a different material with different properties. That's, again, I see a change, so I know it's change. And it's chemical, which means I know that the molecules are going to break apart and reconnect into new materials. That is a chemical change. So if I want to use the physical properties of Pencil Munster here, he's yellow, he's solid, he's made of wood. Those are all properties I can observe about him without changing him at all. A chemical property of a marshmallow is that it can burn. That I know that it's combustible or flammable, so it can burn. That tells me that, again, but to do that, I'm going to have to change it. That's why it's a chemical property. To prove that it will, I'm going to have to change it. Okay, I tear paper, physical property. I want to burn paper. Yeah, it's going to have different properties, but you're not getting that paper back. Remember, physical change, we don't change the material, what it is. You break a pencil, you freeze water, you dissolve salt. The identity of the material doesn't change. If you don't change the identity of the material, you're just physically changing it. Okay, you break a pencil, it's still pencil. However, in a chemical change, you are creating a new substance. Things like burning, rusting, rotting. Those are examples of new substances being created. Signs of a chemical change, like release of bubbles, color change, like the leaves or rusting. When food decomposes, it usually puts out an odor, which is a sign of a chemical change. A release of heat and light is also a chemical change. And the production of a loud sound, we'll do the calcium cannon. You can see a loud sound produced by a rapid chemical change. But again, the key thing about a chemical change is, first of all, they're really hard to come back from, but most of all, a new substance is created when you're done. Again, three most common states of matter: solids, liquids, and gases. Solids, particles are close together, not moving very quickly, but they are moving. Liquids have the ability to flow and take the shape of their container because their particles have a little less attraction to them. They have the ability to flow around each other. And then a gas has particles far apart. But again, whether it's water, whether it's ice, liquid, or gaseous vapor, that's still water. Okay, you're not changing what it is. Solid, definite volume, definite shape. Liquid, definite volume, no definite shape, takes the shape of the container. Gas, no definite volume, no definite shape. It will fill the container that it's in. Now, again, some ways that we know a chemical reaction is taking place. We see bubbles like in baking soda and vinegar. We can see a changing color like in the leaves changing. We can see a change of energy like a glow stick is a chemical reaction, and that light being produced indicates a change of energy and a chemical change is occurring. Now, we can affect the rate of a chemical change a couple ways. The more particles we have, or the higher concentration that we have, that's going to create more particles bumping into each other, the reaction happening faster. The temperature of the reaction. Again, the faster particles are moving, the more they're going to collide, the faster the reaction is going to occur. And then finally, surface area. This is, again, the Jolly Rancher effect. If I have a Jolly Rancher, the saliva is an enzyme breaking down that Jolly Rancher, but it only has the outside surface area to break down. But once you chew it or start breaking it down by chewing it, a lot more surface area is available, and they start to break down much more rapidly because more surface area is exposed. Again, you should understand the process between them. We'll do states of matter again in our next unit, so please don't panic if this is confusing. But from solid to a liquid is melting. Liquid to a gas is vaporization or boiling, depending what you want to call it. And then gas to, well, that's okay. So on the right-hand side, it goes back to gas to a liquid is condensing. And then liquid to a solid is freezing. On the left-hand side, the solid to a gas, not all properties or materials do that. From solid directly to a gas is sublimation. The only one we really commonly deal with is dry ice. And then deposition is the process of like ice forming on windshields or on trees, where it doesn't go to the liquid form first. It just changes directly from water vapor into solid ice crystals. Okay, a chemical formula with balanced equations. Remember, a chemical formula are those symbols and subscripts that represent the atoms of a compound. So if we have water, which is H2O, that tells me there's 2 hydrogen, 1 oxygen in every molecule of water. Every molecule of water. We then expanded on that and said a chemical equation. Remember, a chemical equation basically is showing us a reaction is occurring, and it has to be balanced. So we have 2 hydrogen plus oxygen, and it produces 2 hydrogen dihydrogen oxide or water. And you can see it on the molecular level. We can see it on the balance from the simulation, how all of our atoms are balanced. In the chemical equation, remember, they do have to be balanced. The stuff on the left of the chemical formula is the reactants. Okay, now this is actually bad. Stop it. It's really temperamental today. All right, so the stuff on the left are the reactants. So what we're going to combine is hydrogen and oxygen. So that is the reactants present before a chemical reaction are the reactants. The substances that are available after a chemical reaction, what it's changed into, those are the products. So for example, we talked about photosynthesis. Takes carbon dioxide and water, uses sunlight to make it as a catalyst to make that energy reaction occur. And then you end up with sugar, which the plant uses, and we use if we eat plants, and then oxygen, which it produces as a byproduct, which is also nice for us because it's food use for us. If we are balancing chemical equations, like in the simulation, sometimes we had to use coefficients. Remember, we can't break up the formulas. I can't separate this water molecule to kind of make it balance. What I can do is add coefficients to make sure that it balances out, that every atom on the left is accounted for on the right. Everything in my reactants is in my products. And that's what the law of conservation of mass says, that the total mass of the reactants before a chemical reaction is the same as the total mass of the reactions before or after a chemical reaction. So if I'm burning methane and I get carbon dioxide and water vapor, well, I have 1 carbon on the left, 1 carbon on the right, 4 hydrogen on the left, 4 hydrogen on the right, 4 oxygen on the left, 4 oxygen on the right. It is balanced. Every atom on the left is accounted for on the right. That means I have a balanced equation, which means I didn't lose any atoms, which is good because I cannot lose any atoms. Can't gain any either. All right, I think that's it. So if you have questions about this, you can feel free to review this. But otherwise, this is a study guide for the test. If you understand this stuff and you do the other materials that are available, you should be fine for the test. I appreciate your time. Thank you for listening.